Hello everyone. Today the paper I will be presenting is called Multimodal Misinformation Detection using Large Vision Language Models, and it was published for the CIKM conference in 2024. I will be following this order for the presentation. Misinformation and fake news are false information to the C readers, and they can appear in various modalities, including text, images, and videos. There are existing studies for their detection, but they have limitations. The first is that they primarily focus on only the text data, and they don't use multimodal content. And they assume that the supporting evidence is provided, or they ignore the evidence step entirely. And they do not leverage LLMs or LVLMs. The proposed approach in this paper is that they focus on both steps, evidence retrieval and claim verification, and their key contributions can be listed in 3 points. First one is their novel unsupervised re-ranking method for evidence retrieval, and the second one is that their dataset enhancement. There's a benchmark in this area of research called MOCAG. They resolve the incomplete labels in this dataset and annotate it further, and they do extensive evaluations on both the MOCAG benchmark and the Factify benchmark. If we check the existing studies related to misinformation detection, there are 2 main methods. One is pattern-based methods, and they treat the misinformation detection task as a feature classification task, and they rely on either verifying cross-model consistency or they generate a combined representation of the multimodal features for classification. And the second one is evidence-based methods. They verify the claims by using external information, but most of them still assume that the relevant evidence is provided with the claim. And as I mentioned previously, the MOCAG benchmark dataset is one of the datasets that use the evidence-based method and is also multimodal. So the task of the paper is to predict whether a claim is refuted, supported, or the evidence provides not enough information. And the framework here has 2 main components. One is the evidence retrieval component, and the second one is the fact verification component that uses the retrieved evidences to predict the truthfulness of the facts. For the evidence retrieval component, the goal is to find a sorted subset of n most related evidences from a really big evidence set which contains both text and image. And the thing they propose uses LLMs and LVLMs to re-rank images and text evidences respectively. The first step, they use an initial retriever which they take from the MOCAG paper to get the top and most related evidences. So here they do this just to efficiently narrow down the set of evidences a little bit, and then they use prompting to further make sure that the evidence is actually related to the claim or not. Here you can see that first the initial retriever is getting the top n candidates, and then they are using prompts for both the LLM and the LVLM to check if the evidence is related to the claim or not, and then the models predict yes or no, and based on this they get some relevancy scores. And they use these relevancy scores to re-rank the evidences. And there's the initial ranking scores that come from the method that is used in the MOCAG paper, that is used as an initial retriever in this paper as well. But then the thing they do with the LLM and the LVLMs, in this paper they define 3 different generative AI scores. I won't explain in details due to time limitations, but all 3 of them are basically based on the idea of the LLM and the LVLM to predict the token yes or no, and the probability of the model predicting yes or no, basically. For fact verification step, they are using LLaVA to form the set of multimodal pairs. And for prompting, they use two different versions of prompting, 1 level or 2 level, which at the end is basically just asking the LVLM if the evidence supports or refutes the claim, and if there's not enough information, then it should label the claim as there's not enough information. And then at the end, each claim and evidence pair is labeled, but for one claim there are more than one evidence. So at the end we have to check if all of the evidence, not all of the evidence, but if the majority of the evidence is supporting the claim or refuting the claim, or if there's not enough information, then at the end they do the classification like this. For the experiments, they use MOCAG and Factify datasets, and for baselines to compare the performance, they are using the end-to-end fact-checking method released in the MOCAG paper, and then also they are using this method called Logically on the Factify dataset, and the implementation details are listed here as well. For evidence retrieval, they failed to surpass the results of the MOCAG method for text retrieval, and here in the results K is showing the number of top evidences, so they experiment with different numbers here, but they think that the problem is caused because there are some unlabeled data that is left in the MOCAG dataset, so they first annotate and then do the same experiments, and this way they could improve the results for both methods, and also the proposed method surpasses MOCAG both for text retrieval and the image retrieval, and I will explain how they do the annotation in detail now. Here in the image there's a example claim and labeled evidences for both methods, the MOCAG and the proposed method of this paper, and you can see how they complete the labeling, and they take a subset of the test set from MOCAG, and they use 3 different sets of evidence for each claim in the subset, and then a human expert labels these evidence sets on 3 different levels: entity, evidence, and overall levels. Entity is if the evidence is related to the same topic but doesn't really support or refute the claim, and evidence is it directly supports or refutes the claim. And for overall, if either one of these is true, then evidence is considered relevant. And also they checked how different prompts impact the evidence retrieval phase, and also they check the impact of the re-ranking strategies. I mentioned 3 different relevancy scores previously, and they use all of them, and also the initial relevance scores, and see how each one affects the performance. They experiment with ablated models for the fact verification step. They consider only text evidence as well here, and if you see the results, the proposed method on the multimodal setting surpasses the MOCAG baseline, and also it surpasses the case where we use only text evidence. But still, for the failed samples here, they do some analysis, and they say that the failures of the proposed method are caused by the model's maximum length constraint, and also some of the images have charts in them, and LLaVA is struggling with text recognition from these charts. They also checked how the fact verification step is generalizing on unseen data, and they used the Factify's validation set for this. So the LVLM for FV is falling short of Logically. Logically is another baseline, but it surpasses MOCAG, and it's showing that this approach is adapting to unseen data domains robustly without the need for fine-tuning. To conclude, if we summarize the contributions of this paper, the first one is the novel re-ranking approach for evidence retrieval using LLMs and LVLMs, and they further demonstrate the capabilities of these as rankers. but also they utilize them further in the fact verification step. And even though it's a zero-shot approach, it outperforms a supervised baseline and it has a better generalization capability. But the paper has a big limitation, which is that the evidence retrieval step of the proposed approach is outperforming MOCAG, yes, but the runtime is increasing by 30 times. And for future work, the trade-off between accuracy and efficiency needs to be optimized. That was all for my presentation. Thank you so much for listening.